Yeah, I'm Tim. I'll glad to see everyone here. And the next, 40 minutes or 45 minutes, I'm gonna spend talking about how we use machine learning in IDEs. Maybe some of those you use on a regular basis, maybe not. Yeah, I encourage you to ask questions as we go. Please write them in the chat or feel free to unmute yourself and ask it as you wish. We're gonna, I guess, at the end we're gonna have some time for questions as well. So whatever suits you best. Okay, so I'm not going to talk about our company. I guess the main part here is that we have about 22, 23 years of history, and our the most well-known products are IntelliJ, IDEA, PyCharm, UTrack, TeamCity, Kotlin, and they've been developed for several decades already, and we had a lot of experience of using static analysis tools, and we've been developing static analysis tools for a lot of years now. But at some point, we realized that we have a lot of data, and this data could be also helpful to us. So today, I'm going to talk about one of the features of our IDEs that heavily relies on machine learning. So I guess I need to apologize. This seminar is called LLMs for Code, but today there would be no large language models. Otherwise, I would maybe even argue that for some tasks, you don't need large language models, and classical machine learning tools are as effective as other things could be. But anyway, this talk would not mostly be about choosing the exact model and the evaluation scores it gets, but I'm going to talk about this a bit. But still, I guess I would like to talk about the path that we should travel to make an IDE feature, leveraging ML model inside, and what challenges do we face, and maybe some takeaways for the research community, since I guess most of you here come from academia. So code completion, you start typing a new word, and a pop-up appears with, I guess, more or less relevant suggestions based on something. Today, we're going to talk about single token completion, which I guess is the most conservative and widespread, the one that we have right now. More complex tools such as full line or even snippet-based completion approaches are now actively, I guess, researched, and we have them in different products. But this is a bit different story. So maybe someday I'll talk about that as well. To understand the motivation of why our code completion framework is as it is, let us take a step back and examine this suggestion list. So is this suggestion list good or bad one? You could say that it depends on where I invoke this instance of completion. And you might be right, but in its current form, the pop-up is useless with almost no regard to the context, I could argue. So, and to see why is it useless, we need to look at the code completion usage scenarios and the requirements that we have first. So what do developers need from code completion? One obvious answer is that people want to type less. The fewer keystrokes that are needed, the better. In modern object-oriented languages, developers use very long and meaningful identifiers with camel case or snake case, and you want to input them quickly and with no typos. But I guess a lot of people here write code, and how much time while writing code do you actually spend on typing? I bet that you read and debug code way more than you write it. And even when you do write code, typing is not a major concern. So with code completion, we want to save time and effort spent on thinking, not just typing. This is my hypothesis. And there are also scenarios of like pure exploration, like project exploration, we might invoke completion at some token, or maybe at some like empty line, and see what is happening, what is available, what can I use at this point. So if you look back at this like example we had before, now we can see what's wrong with it. It gives us a 2-letter language keyword, a primitive type name, and 3 pretty trivial items from the call library. So it doesn't have any suggestion that looks like a potential time saver for us. So this is why I argued that it's completely useless. So because of these highly practical points, we don't use generative code completion models here. To get a good suggestion list, our IDEs perform like 2 main steps. So they perform static analysis of the code to find like possible candidates, and then we sort the suggestion list to put the most relevant ones up. Let's see how it works in general. So in a perfect world, we would form a list of suggestions, sorted and present to the user within 100 or 150 milliseconds. So not that much time. In real world, we employ different algorithms for various types of tokens and then merge the results. So we call them contributors. So we gather keywords, variables, classes, and other things, and generate suggestions for them like separately. The exact set of like contributors differs between languages, and each IDE may like break this down in their own way. Well, in the worst case, no suggestions at all may be available, but that happens pretty rarely. On the other hand, well, most of the times we get too many suggestions. So if maybe we have like 800 suggestions, then we have to select the most relevant of them and construct the like initial list of that pops up. Okay, so again, IntelliJ IDEA has more than 20 years of history, and we obviously implemented a lot of manual heuristics to sort this suggestion list. So the most obvious one, I guess, is the logical proximity heuristic. So we treat the names differently depending on where they are defined. If something is defined in the same method, like a local variable, for example, or in the same class, or in the same file, and so on. So with everything else being equal, usually the closer the item definition is to the current position, the better for us. We also use statistics of like previous selections, the lengths of the suggested item, and so on. So I guess for Java, we have the most number of completion sorters implemented. I guess it may be a dozen of them, and they work in chain, one after another. So they re-rank the list one after another. And like eventually, we like every of this like heuristic sorters ends up with like the developer ends up with writing endless if-else statements, because they have like cover all the corner cases and make them work on like all the code that developers might write in their IDE. So yeah, IntelliJ IDEA has been developed for more than 20 years, but what about new IDEs that we have? Most of the IDEs that we have are based on the IntelliJ platform, but still every language is different, and there might be some heuristics that depend on the language. So should the developers of these new IDEs develop those dozens of heuristics for their languages as well? And yeah, it became apparent that we have to delegate this job. So it sounds like it would be like a perfect task for machine learning, since we can train a model that ranks the list. And I guess like for some of the IDEs, some languages, we might even get results better than manually written heuristics. Okay, so the simplified pipeline of the code completion feature I guess, could be presented somewhat like this. And to enable machine learning, we started by building the training data set, obviously. What this data set should look like. I guess the easiest and the most obvious way is the following. There are like thousands of open source projects with like millions of lines of code in virtually every language possible. Oh, sorry. And I guess we can take them from GitHub or whatever. We can take random repository, take random file in it, random position in the file, remove the tail of the token, and then try to complete this this token and see what happens. Since we have ground truth, we know what the token should be. We now can reliably say that it works or not. So while it is very straightforward, this approach, I guess I could argue that this approach has a fundamental flaw. It provides us with a synthetic data set that very much differs from the real world data set. So like in the well-known paper by Herendorn and his colleagues at I guess at IDE 2019, maybe not IDE. But yeah, this is a very good paper that shows that the distributions of different types of identifiers that different data sets contain are very different from the real ones. So they collected some edit actions from like real people from Visual Studio, and they compared this distribution to the ones that we have in the data sets that people use in academic papers. And they've shown that these distributions are different. So if your model is trained on those like artificial data sets, it would have bias. I guess every data set has bias, but still it would have bias, the different kind of bias that the real data usually have. So it's very dangerous to do that kind of stuff, because on your data in your table you would have a great metric score, but like in real world it would suggest like garbage basically. So apart from that, there are also problems. Developers commit their code to some repository, I guess only when the code is in some sense complete. So it compiles, at least it passes some tests, maybe even it has some clear formatting. It doesn't have any duplicate blocks and so on and so forth. So developers like pay attention to what they commit, and like non-complete code is absent from the commit history, and you don't have access to it. So it becomes really hard to understand the distribution of the invocation, like completion invocation points, because when you write like incomplete code, you're still using code completion. But in our data set, we also only have like one side of the story. And again, the proportion of like method calls, variables, and everything else in this data set will be different from the one that appears in the IDEs when users are using that. I guess the biggest issue that we can try to fight all of that, but the thing that we cannot fight, I guess, is that the synthetic data app it doesn't have like features related to user behavior. So, for example, sometimes it takes, I don't know, less than a second for a user to select an item from the pop-up, while in other cases it might take longer time. They might study this list for, I don't know, 10 seconds, 20 seconds before deciding. So is this information valuable for the ranking model? Well, yes, I think it is very relevant. And in synthetic data stuff like this, you never get this data. You never see whether like you succeeded in helping developers or not, and therefore the actual like usage data, like you need this usage data in order to train the model to cover all the scenarios. So yeah, again, in the perfect world, we would like take code snapshots at every completion invocation if we had like the state of your project and we knew that you selected this item from a pop-up. Like, imagine how powerful machine learning completion system we could create. But yeah, that's not happening in modern world. So you might say that, okay, we can have volunteers. We can sign up some people, or maybe some companies even, to participate in our study, and we're gonna ask them to contribute their code or maybe edit actions. And then we are going to have this data set of everything that I've talked about just now. That is great, and some people do that, and like it has great results. We have papers like this, but usually these data sets are, again, limited, because you can recruit like how many people? Maybe a dozen people, maybe 50 people, and it is a challenge in modern days because, you know, of different like privacy regulations and stuff like this, and I guess like companies are not that willing to share the data as they were like 10 years ago or so. So again, you might have a limited number of people, and this automatically brings bias to the data set, because, you know, if you only work with one company, well, you would have the model would learn how things are done in this particular company, in this particular domain even, or maybe in this particular project, and like everything else is a mystery, I guess, again. And yeah, it's hard to recollect this data set when you, for example, like in a year or so, you are trying to update the model, you know, when, for example, some changes in the language happen or something else. And still, you have to redo everything and, again, deal with like privacy regulations and everything else. But okay, you could say you're JetBrains. You have like millions of users, and you have all the code that they write within your product. So why don't you just collect everything? And now you have all those tiny actions in your IDE. You can log them and train the best model that could be, basically based on this data. Yeah, having all this code in our hands, we can use all kinds of LLMs and other powerful models that we can employ. But, you know, this image is generated by DALL-E, and the prompt was JetBrains developer in jail. So yeah, I guess this is how it sees us in jail, because, you know, just taking data from users without their consent is not realistic. We'll get sued like this. So we have like GDPR in Europe, we have CCPA in the US, and like basically it's like it seems like we're stealing their code to monetize it, basically, because we are selling our products, and they have this feature that we will have a model trained on the data that we have no rights to use. So again, this is a no-go. What we decided to do? So we solved this problem by collecting completion users logs in an anonymous and depersonalized way. So all the fields in our logs are either enumerable or numeric. So we don't store any binary blobs, free-form texts, like hashes of the code, libraries, lists of libraries you use, or anything else of the sort. So if you're interested whether we are looking at your code or not, the answer is like, no, we don't. And moreover, we do a lot of things that to avoid logging your code accidentally. So we have a very strict logging policy that everything is forbidden unless it is explicitly permitted. And there are several levels of review in order to change the list if we want to add something else to this logging. So we do everything we can to avoid leaking the code, and no, like, we only store numbers and, again, enumerable values, which are, I guess, basically also numbers. So let's look at these features in more detail. So the aim of the features, like in general, is to describe the completion context of like every given suggestion the best way possible without actually giving away any of the written code, as I just explained. So the context here relates not only to the code right before the caret, but basically anything that can influence this choice. So there are several groups of language agnostic features, and there's like language specific features. I guess the major source of information about the completion is the prefix. So the already typed part of the token before the caret. The information includes the length of the token, the number of matched characters between the prefix and the suggestion, whether the match is case sensitive, whether it is exact, and like a lot of other things. The completion session, again, doesn't happen in a vacuum. It takes place in certain code locations, in certain parts of the code base. So I guess the context also influences the necessary token. The features that we collect here are like whether the suggestion is a language keyword, whether the suggestion is element from the same file or from the same module or from some library and so on. Syntactic history. So yeah, it's very important to catch the dynamics of what's happening in the IDE and not like treat this file as a static object. So we look at previous actions that users might have and whether this influences the decision. So for example, if the user navigated to the definition of some method, then it could be information that they might find this method useful in this context, and it like seems more important. And we also have this temporal aspect of completion sessions, the duration of given session in seconds, whether this like user has already suggested the given suggestion before, and so on and so on. So these are language agnostic features, and you can see that they like pretty much they describe a lot about the completion session. But still, again, there are language specific features that depend on the language grammar, or I don't know. For example, how far is it from the init method in Python or something like this. So we've initially we had several hundred of such metrics, and then we try to see like feature importance and apply different techniques to see whether the model actually uses the data or not. And in the end, I guess the list is different for every language, but it's somewhere near 150, 180 features or something like that. So yeah, I have an example to showcase that. So imagine you have this fragment of code, you are trying to write a bootstrap function, and you call this completion invocation after you input this C character. So I guess the most logical call is random.choices here, and like what before showing the suggestion list, what we can get from this. So we have like a lot of information. The pop-up is invoked automatically, for example, as opposed to pressing command space or control space. And this is a like enumeration value. The indentation level is 2, which I guess is critical for Python, but well, it could be important for other languages as well, which is a number. The prefix length is 1 character. Again, the number, not the character itself. The parent type of the character location is a loop. The invocation happened in the middle of the line. The invocation happened after a dot, and like a lot of other things. So even before the suggestion list appears, we get some very important information. So again, we log this data. We have like now it to analyze, but within like 100 milliseconds or so, this pop-up appears, and like it might look like this. It doesn't really matter. So it takes you about a second to figure out what you want to well, I guess faster, but still, let's imagine that it takes about a second for you to decide. You scroll down, select the second item, and again, what we can learn from that, the delay that before the user acted was about 1100 milliseconds. The user action, which is a number, the user action was to select an item, which is one of the enumeration value. The selected position is 1, and so on and so on. So again, we have some numbers that describe what happens. And that way we collect like everything, then we send it to our servers, and as you can see, it contains no information about you or your code. So yeah, getting back to this data collection approach, it kind of solves all the problems typical to synthetic data sets. And like, since these features are collected directly from the users as they use the IDE, we are able to do online testing, right? So there's an obstacle. First of all, we cannot collect a data set of such kind without users. So yeah, to collect a data set, we have a completion model. We need to have a completion model. But to train a completion model, we have to have a data set. So we have the chicken and the egg situation that we should like unravel. We'll get to that in a second. But before that, I just wanted to mention another challenge of training a model without actually having the source code. So like basically all you have is like those vectors of numbers got from a lot of different users writing different kind of code. And like when you are training a model, I guess a lot of you do train models. Sometimes something goes wrong. You run it on some data. You see some surprising results. What do? You look at the data. So why did the model behave like this? So how did it learn this kind of behavior? So you look at your training data, and we cannot do that. So all that we have is a bunch of numbers that describe the code, the context, the behavior of the users, and so on, but we don't see the code itself. So we cannot look at the code and try to figure out if something goes wrong. So sometimes it gets to very tricky situations, and I wanted to share one of such cases with you. So there was a case. We noticed that a group of users very seldomly shows anything from the completion pop-ups. So the group was very big, quite big. Like to explain, but we could say that it's like an outlier, some statistical outlier, and we can ignore that. But the group was quite big, so we cannot ignore that. We started to see how this group was different. These people, they had like the same level of activity. They used the same programming languages. The completion pop-up appeared with the same frequency for them as for other users. So like they were basically the same, but for some reason they didn't use completion pop-ups. And like if in a perfect world, we just looked at their IDEs, at their code, and tried to understand what's happening, but like obviously we couldn't do that. So we checked like several things. And we concluded that somehow something was broken in the IDE. So the relevance scores, the top suggestions were much lower than usual for other users. And like, what should we do? Well, I guess yeah, this is the answer. So all of them had this option enabled in the completion settings. So for some reason, they prefer alphabetical suggestions, like suggestions sorted alphabetically. So they can't even see the best options because, well, the alphabetical sorting makes like it very straightforward. So the options that they needed were not on the screen, but the suggestion list appeared. So I don't know why people use alphabetical sorting in 2023, but still some people obviously do. And when we got this, we added another feature, whether the user has some alphabetical sorting enabled. And if it is, like we just ignore this in our training sets because, well, it gives us basically no information. Okay, so getting back to this chicken and the egg situation that I described before. So again, we needed a data set to train a model, but to collect a data set, we need to train a model, we need a data set, but to collect a data set, we need a model. Surprisingly, it's solved via bootstrapping. So in our products, we have this thing called the Early Access Program, or AAP. So basically, it gives anyone who participates free access to pre-release versions of our software. And like it allows you to evaluate new features. And like we get some data in return. So again, we have several thousand people participating in this program like every year. And now that we have data, it's actually time to train a model. I guess I'll be brief here since I don't have a lot of time, but we have a lot of requirements that actually like not allow us to use large models such as like even transformers or other neural models. So we have like this feature is very conservative. People should have it out of the box, and it should work at every keystroke. So again, it should be very fast. It should be very reliable, and it should work again out of the box. So there should be not like any downloads from the network of some models or some vocabularies or something else. So it's funny to see research papers that like state that, well, okay, we trained the completion model and like it is 2 gigabytes of memory. So no one would like, no user would commit to download a 2 gigabyte model to improve their completion, 1 or 2%. So our limitations are very strict. It has to be a fast model, and it doesn't need it shouldn't take a lot of the user's memory because memory there's not enough memory most of the times. So we decided to use decision trees in the CAD Boost framework because it's very lightweight, and it could be easily converted in a sequence of if-else operators, which could be implemented in pure Java, and they would like extremely fast. Yeah, there like some critique of the feature-based models, but I guess I'm gonna skip that since we don't have a lot of time. The one thing that I wanted to cover here, since to be a bit more technical, I guess, is the loss function here. So again, when we're training a model, we need to develop some kind of a punishment system that forces the model to perform well in situations like you consider essential. So again, for a completion model, there's only one parameter that can commit, not putting the best suggestion on top of the list, right? So when we are training a, I have a question. If possible, could you say why the response should be less than 30 milliseconds? Also the same for model size. So I guess it comes from experience, the model size, because, well, our IDEs are not very lightweight, at least right now, and like adding every feature counts. So basically adding extra couple or even dozen megabytes of memory, it is important. And when you come to a production team that develops some kind of a product, they're very careful about that. And the 30 milliseconds, this completion, like machine learning breaking, happens on top of everything else. So all the heuristic sorters that I've talked about are still on, and like they take some time, and like having extra 100 milliseconds on top of that would give like worse user experience. So if you have 150 milliseconds for a response, that I guess looks very nice and smooth. If you have 300 milliseconds for response, people start to notice that just like a physiological fact. So we have to like stay in this limitation. Okay, so yeah, I hope I answered this question. When people train ranking models, the default metric, or maybe a lot popular metric, is RMSE, root mean square error, which kind of tries to put relevant things higher than lower, and it makes sense for I don't know, relevance-based ranking tasks such as search engine, because you operate in the shades of gray. But here it's very binary, whether you put this the best thing that the user wants to select on top or not. So again, in this example, these two completion lists and which of them is better, I would argue that they're both very wrong, because, well, putting like the model would be very happy with RMSE. The model would be very happy to move the correct answer from position 200 to position 50. And numerically, it is a huge improvement, but like practically, it's very unhelpful. So we switched to the best position only, so the first position only. We found this loss function from this paper mentioned in the slide, and we found the implementation of this long loss function in CatBoost. So we retrained the model with this long function, and we got a 10% increase. So people started to select items from the completion pop-ups 10% more often than before. So I guess this mattered. Okay, so I guess we move to the evaluation of this. Well, our experience shows that you don't need a lot of data to train such a model. In our case, it was somewhat about 30,000 data points. And we get them from the users of EAP releases. We split them by time, so we don't want to peek into the future, like general stuff. But before testing on humans, we wanted to see how it behaves on the unseen data, the data that hasn't seen during training. So we collected 2 weeks of user logs, trained the model on the first week's data and tested on the second week data. We use the recall at K metric, which I guess is, well, the most important one is recall at 1, which I guess the very top choice for the user. And we also like calculated not across like all lookups in all completion sessions, but also only for initial lookups. So meaning that, well, the first lookup that you have in a session before actually typing anything, it correlates, I guess, the best with the user experience. Question: I didn't understand which ML or deep learning method is used during training. It was decision trees. So this like classical decision tree algorithm that well, is ignored these days, I guess. So we tried a lot of different things, including like GBM. We tried feed-forward neural networks, transformer-based neural networks. But you see that with this severe limitation on the size of the model and the time of inference, it's really hard to train a well-performing transformer. And everything else was not like as good as decision trees. So surprisingly, we still use the classical machine learning approaches and not the fancy neural networks that everyone is so obsessed about these days. Okay, so getting back to this evaluation thing, we can see that the most important metric is recall with 1, and we get the best increase in the quality in this metric. So it increased by 16.5 percentage points. Sorry. So yeah, indicating that we will most likely have better performance for the new model. So yeah, I'll just try to wrap up and have time for questions. So we deployed the model, and since we now have it online, we can have online evaluations. And again, I'm going to have a link to the paper. You can get everything from there, but we have several different kinds of metrics that show how actually people use the model. So how many symbols they typed, how many things they selected explicitly by like selecting things from the list, or like what was the prefix links of what they typed. And for most of the metrics, we got statistically significant improvements, again, on real people. And you can see that the trained model is very small. It's like less than 400 kilobytes, which is very good. And the latency increased from 92 to, well, roughly 120 milliseconds, which I guess is also very good. So we were very happy with these results. So yeah, we got our model, we put it online. What's next? So it would be like naive to believe that we got the best model possible. So we need some kind of a iterative process to collect new data sets, train new models, compare them, and so on. So I guess, well, the most important feature, feature of this approach is that gathering of new data and the evaluation of the models actually happens in parallel, since both of them rely on collecting logs. So again, the cyclical nature of IDE releases means that the process could be repeated over and over, and we can collect new data, and we can train new models, and we can evaluate them on real users, and so on and so on. So in each AEP release, we perform an A/B experiment, which I guess is not that which is not happens very often for desktop project, but still, we randomly split all users into buckets and show them different completion models. So for example, at step I, we have the previously best working model, and we have some new candidates. We show them to different users, and we compare how they are performing. And we have a separate group of users that use the previous best working model, but we were not using them for the evaluation. We use them to collect the data set. Then we train the next model, we compare it to the current best performing model, and we use the, again, separate group of users to collect data set for the next iteration. So this happens several times a year, and this allows us to continuously fine-tune our models, adapt them to new environment, to new features of the language, fix different things, try new features, and so on and so on. So yeah, this basically happens at every EEP release. So yeah, I guess this process is active since the end of 2020. So if you've been using IntelliJ-based IDEs for any of those languages for the past 2 years, you've been experiencing maybe not this data collection process. This happens only in EEP versions, but still you've experienced the completion engine based on that machine learning approach. So yeah, to sum up, I have some takeaways for you. So first of all, creating a code completion system using fully anonymized logs as training data is totally possible. It's a lot, it could be inconvenient a lot to debug, but it's still doable. And a lot of people, they find it very surprisingly so when I talk about this. We don't have a large data set. We have about 30,000 completion sessions, which we collect from our users. And yeah, I understand that it's hard to do this if you're not JetBrains. So to enable this for the community, we are inviting you to collaborate with us on this. If you have an idea of how this approach could be used for the tasks you are solving, and we are happy to extend the log infrastructure to collect new things. and like explore different tasks. So yeah, drop me a message, we'll talk and see whether it's possible to loop you into this as well. So yeah, I guess the target metric selection is critical. If you are aiming for the winner takes all strategy, don't use M.Sc, use something else. And the third thing is that only online evaluation can actually prove that you are succeeding in bringing value to end users, because like, again, a lot of academic papers calculate some like F-score metrics or something like this on their data set, and they make conclusions that they now help users better. I'm totally fine with like reporting F-scores. It's a natural like step of the process, but it doesn't tell like anything about helping users. It's a score based on some data that you have. Here's the paper that describes a lot of things apart from what I've been talking about. If you're interested, please go and read this paper. And I wanted to conclude with this diagram that I took from a PhD thesis of my colleague. It shows the life cycle of data-driven feature in like software engineering tools. So researchers in academia mostly work on data-driven techniques, publishing papers where they compare these techniques to like alternatives and baselines. Some people make an extra step and develop like a tool, providing other people the means to actually use this feature. Well, it requires a lot of additional work, and like gladly we have like tool tracks on software engineering conferences, and a lot of people do that, which is great. But to actually make an impact with your work and make this feature part of the production level tool used by hundreds, thousands, or even millions of people, usually a lot of extra work is needed. And definitely you will need some help from the vendor, which we are and which we are happy to help you with. Yeah, I also have this slide, which shows a prototype of a new feature that we are working on. It's like a very early stage prototype. So yeah, we are like looking for feedback. If you're interested, you can go and try it. I hope it will be released later this year, maybe sometime in summer. But again, this is a speculation. Don't listen to me. If you're interested, go and use it. It works for several languages. And with that, I'm finally done. Thank you for listening. If you have any questions, we have like 8 more minutes to talk about them. Yes, we have a question in the chat. How many iterations the trial period has? Could you elaborate what do you mean by the trial period?
When users sign up to test their models.
Every AP lasts for 2 months before the release. So during this time, we have 3 releases a year, so every 4 months. So you have 2 months of not having an AP release and then 2 months of AP, and that happens. So during this 2 months period, we might try several models, even if we if we see that we can get feedback. So yeah, it happens every 2 months. And what is number of iterations the models require to converge? Oh, I'm not sure. I'm able to answer that right now. Well, but again, iterations meaning the EAP releases, right?
You have, let's say, 7 models during that time. So I'm just curious, how different are they from each other, and like how well they perform?
Yeah, but
is the last one significantly better than the first one?
So in every A/B test, we can test like several models that are trained on the data collected from the previous release. So I guess it takes data collected from just one AAP release to train a model, so you don't need to wait for several of them. As I showed you, it requires maybe a week of user data, so that could be easily collected, and you like it is required to train a model like fully. So you might even have several iterations of this A/B test during one IDE release. But we try like sometimes, well, there were tests, there were cases when we tried like 7 models simultaneously comparing different things. And not all of those improvements actually improve the quality. So sometimes we proceed with the previously best working model to the next release because, well, sometimes they are just experiments that don't lead to anything. So yeah, that happens. That's no big deal. Our data set and code publicly available? I want to implement it and use it during my master's thesis. Yes, we have some of that implemented in the community version of IntelliJ platform. So if you go to like GitHub/JetBrains/IntelliJ community or something like that, you can find this code there. I think that, well, maybe even everything is open source. So I'm trying to remember whether maybe some of the features are not, but a lot of language agnostic features should be open source. So yeah, if you cannot find this, drop me a message. I'll send you a direct link. So I don't want to spend time right now to find it. I have a question about the line-based code completion that you demonstrated at the end. How does the line level code completion compare to large language models such as GPT-4 based code completions? Additionally, how do you evaluate your technique for line level code completion or data sets used for evaluation available? These are very good questions, and we are working on a paper about that, but it's a work in progress. And like the short answer is like nothing is open source yet right now. Maybe it will be when the feature will be ready and will be released. So but to give you like a sneak peek, it has much smaller models under the hood because it happens on the client's computer. So it's not like a server-based thing, the one that I showed you. So no, I should stop here. I'm not allowed to say more. But yeah, it behaves like worse, obviously, than GPT-4 based code completions because like the size of the models are incomparable. We have some ongoing work in the direction of large language models, and I think that we are going to release some things later this year. So stay tuned, as they say. But the data, I think we are going to open source the evaluation part of this technique soon enough. We are doing it right now. Maybe in a week or so, it will be open source. If you want to, we use a very like new and interesting technique to evaluate for line code completion code. I think it's called code golf or something. Well, working progress name. So yeah, we're going to open source the evaluation part because we have some tricks with like tokenizing the code and everything else. So yeah, if you're interested, drop me a message in a week or two, and I guess I will be able to share the code. But the data set, I'm not sure if we're going to release it or not. I'm not sure even if I can talk about how we collected this data set, but it was like totally legal and stuff like this. So again, this is like an uncharted territory for me. I'm talking about the things that are under NDA, and when they are released, I'll be happy to go and talk about it. And again, we're writing a paper that we're going to submit to ICSE or FSC, the next one. I guess it would be ICSE, like the deadline is somewhere in October, so we might have time for that. So yeah, stay tuned, and we are going to talk about this in detail a bit later this year. Okay, I think I'm done with the questions from the chat. Anyone else?